The complete middle school study guide. Everything you need to know to ace math in one big fat notebook. Notes borrowed from smartest kids in class, double checked by award-winning teacher. Math. This is the contents of the book. It's chapter 1. Unit 1. The number system. Types of numbers and number line. There are many different types of numbers with different names. Here are the types of numbers used most often. There's whole numbers. A number with no fractional or decimal part cannot be negative. Here's an example. Natural numbers. Whole numbers from 1 up to 1 and up. Some teachers say these are all the counting numbers. Here's an example again. Okay. Integers. All whole numbers, including positive and negative whole numbers. Rational numbers. Any number that can be written by dividing one integer by another. In plain English, any number that can be written as a fraction or ratio. An easy way to remember this is to think of rational root word ratio. Here's an example. Here's some examples. It says here, the line over the 3 means there that repeats forever. Irrational numbers. A number that cannot be written as a simple fraction because the decimal goes on forever without repeating. The dots mean that it can continue on forever. Here's some more examples. It says here, every number has a decimal expansion. For example, 2 can be written as 2 decimal zeros. However, you can spot an irrational number because the decimal expansion goes on forever without repeating. Real numbers. All the numbers that can be found on a number line. Real numbers can be large or small, positive or negative, decimal fractions, etc. Here's how all the types of numbers fit together. Real numbers, irrational numbers, rational numbers, integers, whole numbers, and rational numbers. -2 is an integer, a rational number, and a real number. Example. Some other examples. 46 is a natural, whole, and integer, irrational, and real. 0 is a whole, integer, rational, and real. Numerator 1 and denominator 4 is a rational and real number. 6, 6, 7, 5 is a rational and real. Terminating decimal, or decimal that end are rational, or decimal that end are rational. This number here is a irrational and a real non-repeating decimal that goes on forever. Are rational. Rational numbers in the number line. All rational numbers can be placed on a number line. A number line is a line that orders and compares numbers. Smaller numbers are on the left and larger numbers are on the right. Example 2, because 2 is larger than 1 and also larger than 0, it is placed to the right of those numbers. Continue on. Similarly, because -3 is smaller than -2 and also smaller than -1, it is placed to the left of those numbers. Here's another example. Not only can we place integers on the number line, we can put fractions, decimals, and all other rational numbers on the number line too. Here's checking something to check your knowledge, a page to check your knowledge. Let's go on to the next, chapter 2. Positive and negative numbers. Positive numbers are used to describe quantities greater than 0, and negative numbers are used to describe quantities less than 0. Often positive and negative numbers are used together to show quantities that have opposite direction or values. All positive numbers just look like regular numbers, and positive 4 and 4 mean the same thing. All negative numbers have a negative sign in front of them, like this. Reminder: all positive and negative whole numbers without fractions or decimals are integers. As we know, all integers can be placed on a number line. If you put all integers on the number line, 0 would be at the exact middle, because 0 is neither positive nor negative. Positive and negative numbers have many uses in our world, such as negative, positive, debt, money that you owe, money that you keep. Yep. Next page. Debt from a bank account, credit from a bank account, negative electric charge, positive electric charge, below 0, below sea level, above sea level, above sea level. On a horizontal number line, numbers to the left of 0 are negative, and numbers to the right of 0 are positive. Numbers get larger as they move to the right and smaller as they move to the left. We draw arrows on each end of a number line to show that the numbers keep going all the way to infinity and negative infinity. Infinity, something that is endless, unlimited, or without bounds. Positive and negative signs are called opposites. So positive 5 and negative 5 are called opposites. They are both the same number of spaces or the same distance from 0 on the number line, but the opposite side. On a vertical number line, such as a thermometer, numbers above 0 are positive and numbers below 0 are negative. Example: what is the opposite of 8? -8. Example: Devin borrows $2 from his friend Stanley. Show the amount that Devin owes as an integer. The opposites of opposite properties say that the opposite of a number is the number itself. Example: what is the opposite of -16? The opposite of -16 is 16. The opposite of 16 is -16. The opposite of 16 is -16 is -16, which is the same as itself. Here it says, you said I could go to the movie. I did. Well, you didn't say I couldn't go. You're really stretching the opposite rule too far. Check your knowledge. Here's again a page to check your knowledge. You can pause to look at the page. Next chapter. Chapter 3. Absolute value. The absolute value of a number is the distance from 0 on the number line. Thus, the absolute value is always positive. We indicate absolute value by putting 2 bars around the number. Example: here they put 2 bars around -4. That is read the absolute value of -4, because -4 is 4. Space is from 0 on the number line. The absolute value is 4. Example: 9 is read as the absolute value of 9 because it is 9 spaces from 0 on the number line. The absolute value is 9. Yep, see. Absolute value bars are also grouping symbols, so you must complete the operation inside them first, then take the absolute value. Sometimes there are positive or negative symbols outside the absolute value bar. Think inside, then outside first. Take the absolute value of what is inside the bar, then apply the outside symbol. See. The absolute value of 6 is 6, then we apply the negative symbol on the outside of the absolute value bar, so we get the answer -6. Now this changes everything. That's what it says down there. Okay, here it says example: the absolute value of 16 is 16. Then we apply the negative symbol on the outside of the absolute value bars to get the answer -16. An answer in front of the absolute value bar means multiplication. I like when we use parentheses. Example: the absolute value of -4 is 4. Once you have that value inside the absolute value bar, you can solve it. You can solve normally. Multiplication can be shown in a few different ways, not just with x. All these symbols mean multiply. See, yeah, all those symbols. If you use variables, you can put variables next to each other or put a number next to a variable to indicate indicate multiplication, like so. variables. A letter or symbol used in place of a quantity we don't know yet.